Welcome students to the computer science class. In this tutorial, we will learn and discuss about computer memory. That is the second chapter of your book IT Planet. In the previous chapter, when we have read about the fundamentals of computer, we have seen the various hardware parts of a computer system, like the input devices and the output devices. We have also discussed about the storage unit, the processing unit of a computer. So here we will see the storage unit or the memory unit of the computer in detail. So what are the different memories? What are the different kind of storage a computer system uses? A computer system might be using. We will see that various types of memory, that is the primary memory and the secondary memory that are used in a computer. The primary memory or the RAM are mostly volatile in nature. That is, they loses all its contents as soon as the computer is turned off. So it is a temporary memory that is used by the processor of the computer. The processor can process data that are present in the RAM. It cannot process data, it cannot execute the instructions that are present in the secondary memory. If you want to execute some instruction, if you want to execute a program, a software that is present on your hard disk, you have to, it should be loaded on the RAM first. And then the processor can fetch the data and instructions from the primary memory, that is RAM. Now why is this? Both are used, both are the memories. Primary memory is the memory, secondary memory is also a memory. Why is the difference? What is the difference between this primary and secondary? The difference is the secondary memory is used as a storage, as a backup storage or a permanent storage area of a computer. Generally, it is not very costly. Generally, these are slow devices that can keep your data permanently. But primary memory are faster devices, not as fast as the processor. It cannot transmit data as fast as the processor needs, but it can at least match with the speed. There is a differential between the speed of the processor and the speed at which the primary memory can transmit data. But still, it can cope up, it can match to a certain extent. And to match with the processor, match with the speed of the processor, there is a even faster memory called the cache memory of the computer. This particular memory is built in within the processor itself. So as it is very fast, the processor checks for data and instructions in the cache memory. If the data is not found in the cache, it searches for the data in the RAM, that is the primary memory of the computer. As cache is very fast, the capacity of cache is very low. We cannot use a cache that is having a high capacity because it is very costly. A cache is a very costly memory and it can improve the speed of the computer. So, the frequently used data and instructions are kept in the cache. So, whatever instructions are executed frequently are kept in cache. Whatever data are processed which are required by the processor are kept in the cache. So once something new is required that is not present in the cache is searched in the main memory, that is RAM. When that data is not found in the RAM also, it is fetched from the secondary memory, that is the hard disk or a pen drive or a flash memory or a CD-ROM drive of your computer. So the computer fetches inside the computer, the data is transmitted according to hierarchy. When the computer boots for the first time, when the computer is turned on, the first software that is loaded is the operating system. Where is the operating system? It is already there inside your secondary storage, that is the hard disk. So from there it is loaded into the RAM and the computer becomes in the working condition. It gives you an interface. The operating system gives you an interface so that you can give commands, you can see your programs loaded, and you can run the other applications on the interface. When the operating system is loaded on the primary memory, you can see all the application softwares that are installed on your computer. That does not mean that all the application softwares are there on the primary memory. You can see only the icons. It is the interface which is showing the icons that are installed on your computer. That does not mean all the applications are on the primary memory. As soon as you click on a particular application, on the icon of a particular application, it gets loaded into the primary memory. For example, if you double click on your music software, on your MP3 player, you want to listen to the music, that particular software will be loaded onto the RAM from the hard disk. You want to browse the internet, you click on the browser. The browser software gets loaded onto the RAM and you can see the browser running on the monitor. You can see the interface of the browser. So in that way it works. It fetches the program from the secondary storage on the RAM and you can see the output on the output devices. So in this way the primary storage and secondary storage coordinates and the instructions are executed one after the other. You get some work done. After you generate some result, the result is also on the temporary memory, that is the RAM. If you want that result to be used, if you want to utilize those results in the future, you have to save those data, you have to transmit those data on the secondary storage, that is your hard disk. Transferring of data from primary storage to hard disk is called saving. So when you save, you transfer the data from primary storage to secondary storage so that you can get it back in the future. So we will see all these things in detail in this chapter. Okay, let's start with the chapter. Computer memory plays a very important role in a computer. And what is the important role? I have said you just now. It gives you the storage area for your data and instructions. It is the basic unit where data and instructions are stored temporarily. Now, when you say the word memory, the term memory, it refers to the primary memory and not the secondary memory. So that's why it's temporary. It's temporary in nature. It is the basic unit where data and instructions are stored temporarily. Memory usually consists of one or more chips on the board, on the motherboard. It stores instructions waiting to be executed by the processor. Data needed by those instructions and the results of processing the data, that is information. So it stores the instructions that are waiting to be executed by the processor. What does that mean? When I am executing this this PDF reader software, what I am doing? I am executing a software, an application software. What is the purpose of the software? The purpose is to read a particular soft copy. That is the soft copy made by scanning the images of a book. So I can read the soft copy with the help of this PDF reader. So that purpose is properly served. So there are instructions which are loaded into the RAM of this computer due to which this is running. There is a particular kind of interface. You can see the file menu is there, edit menu, view menu, sign, window, help, all these are there. So I can click on them and I can see the various instructions I can execute. I can open a new PDF file, I can reopen, I can create a PDF, I can save the PDF, the changes made to the PDF I can save. So whatever I can do, I get it in this menu, in the form of a menu. So this is called an interface. The look and feel of the instructions of the environment of the software is called the interface, through which we can control, through which we can instruct, through which we can get the output. So all these instructions are there resident in the primary memory, which are being executed by the processor. So memory stores the instructions that are waiting to be executed by the processor. Now these are the instructions that are there on the primary memory. As soon as I click, the instructions will be executed. It is it will not execute till I click them, till I tell the processor to execute them. So it waits for the user's command. It waits for the user to instruct. The functions are there. These are all the functions, the modules are present on the RAM. As the software is running, the associated instructions are also waiting on the RAM. As soon as the user clicks on a particular command, it will execute. So memory usually consists of one or more chips on the motherboard. And on the memory module there can be two or more memory chips that are fitted on the motherboard. It stores the instructions waiting to be executed by the processor. Data needed by those instructions. Not only the instructions but also the data that are needed to be executed for generating the results, for processing the data, like this. Everything is there, you are executing is there on the memory. A computer system is also equipped with some additional memory devices which are generally used to store programs, applications, data, and information permanently. Before studying about different types of memory, we will study about the memory units. So they have both kind of memory, that is memory for temporary storage, storing data temporarily, memory for permanent storage, equipped with additional memory devices that are used for storing programs, applications, data, and information permanently. Okay, so both for temporary storage and permanent storage, the computer has got memory. The temporary ones are the primary and the permanent ones are the secondary storage devices. Just like now the memory units, like the solids are measured in grams or kilograms, liquids are measured in liters or milliliters, computer memory is measured in bits or bytes. Now what is a bit? A 0 or a 1 is a bit. If you write a 0, it's a bit. If you write only 1, it's a bit. A computer processes and stores data and instructions in the form of two digits, 0 and 1. The digits are called binary digits or bits. A bit is the smallest unit of information that a computer can process and store. A group of 4 bits is called a nibble. You can see there are 4 bits, 1, 2, 3, 4. 4 bits is called a nibble. Again 4 bits is called a nibble. A group of 4 bits is called a nibble. Nibble, nibble. A group of 8 bits is called a byte. So when you group them, when you combine two nibble, you get a byte. That is a group of 8 bits is called a byte. A byte is the minimum space required to store a character. It is the minimum space that you require to store a character. right? So if you there are so many keys on the keyboard. On the keyboard you see so many keys from capital A to Z, 0 to 9, small a to small z. You can actually see only the capital letters, and you use the shift key or the caps lock to turn it to small letters, right? So when the caps lock is off, you get the small letters. When the caps lock is on, you get the capital letters. You can see the the numbers. You can use the different symbols. So all these are the characters, and for storing each character you need a byte. A byte is the minimum space required to store a character. So when you write a single character, you are using 1 byte of memory, that is this much of length. There are 8 bits required to represent a single character, like that. So you can see there is a table given. 1 byte is 1 character. 1 kilobyte is 1024 bytes. So if you are writing your name, if your name is having 5 letters, then how many bits are you using? You are using 5 into 8 is equals to 40 bits, because each character is having 8 bits or a byte, and you are using 5 byte. So there are 5 characters in your name. You are using 5 byte or 40 bits. Now, what is a kilobyte? It is 1024 byte. What is a megabyte? It is 1024 kilobyte. What is a gigabyte? It is 1024 megabyte. What is a terabyte? It is 1024 gigabyte. So like this, the greater the unit, the greater the bigger unit, bigger hierarchy, the bigger level of unit you go, you just multiply it with 1024. So when you come to kilobyte from byte, you multiply byte with 1024, you get a kilobyte. You multiply 1024 with a kilobyte, you get 1 megabyte. You multiply 1024 with megabyte, you get gigabyte. So in this way, you get, you just see, you just memorize byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, yottabyte. So this kind of huge storage for yottabyte, zettabyte, these are used on servers that needs huge storage area for storage, for permanent storage. You can assume, you can think of the mail server. Thousands of people are having account on Gmail server. So how are they stored? They are stored on the on a special kind of computer called server, having huge storage area. So this storage space is of the order of this. It may be petabyte, it may be exabyte, zettabyte, or whatever. It's according to the requirement of the server, right? So bigger units are required for bigger storage devices. Next, for a brief idea about the computer memory, or what is the physical how much physical information can be accommodated within a particular unit of memory, you will get a brief idea about it. Here you can see only a page of the document of a book is there. So what is the space it is occupying on the computer memory? Here is a whole book. How much space it is occupying on the memory? There are few books. How much space they are occupying on the computer memory? And there is a whole shelf of books. How much space are they occupying? So that will give you an idea regarding how much space might be required to store books of your library. If you want to store all the books of your library, what is the amount of space, what is the amount of memory you may require? Now, when we are telling about you may require, it is always considering about a particular kind of resolution of the document, of a quality of document. If you, because you know the quality, there you can have the best quality documents, the pictures are of the best quality, then the space will also be a huge one. If you require only a standard one, just you need to read it, then it will minimum quality will be sufficient for your use. So that is about resolution of a image. When you are scanning a particular book, you are selecting the resolution, that is dots per inch. So more the resolution of the image, more will be the quality of the image. So if you want a good quality of the document, if you want good quality of images, the space requirement will also be high. So that you have to consider. Okay. See, 1 byte is equal to 1 character. You know, so 8 bits equal to 1 character. A character can be a number, letter, or a symbol. So if you write a symbol, you are using 8 bits. If you are writing a letter, you are using 8 bits. That is 1 byte. 1 byte consists of 8 bits. A bit is the smallest unit of information computer can process. 1 kilobyte is 1024 bytes. This is approximately equal to 1 page of a textbook. So 1 page, 1 kilobyte. That is 1024 bytes. There can be 1024 bytes. Okay. Means how many characters? 1024 characters. 1 character is equals to 1 byte. So 1024 characters, up to 1024 characters, it can store in a KB. Again I am telling, if it is having some pictures or if the resolution is high, then it will take, it may be 2 KB or it may be 3 KB or 5 KB. That will depend upon the quality of the document, right? Quality of the image. Next, this is only a assumption. The minimum amount of memory you may require is 1 KB. So to store a page, you need minimum 1 KB on the memory, on the computer memory. To store a whole book, you need 1024 kilobytes, that is 1 megabyte. So the whole book is equal to 1 MB. Now, after that, you can well assume how many books you can keep in 1 GB. When you can keep only one book in 1 MB, then 5 books of equal length. Suppose 5 books having same number of pages. So in 5 MB you can keep 5 books. If the number of pages in the second book or the third book is more, then you will require more pages, more memory. So like that. So approximate memory requirement for a book on a particular rack, 1 gigabyte. This is approximately equal to bunch of books. 1 terabyte approximately equal to the entire book stand. So this one is too high. They have measured it bigger. I think this is a bigger unit they have allocated. Within 1024 gigabyte, you can keep a huge library of books. Right? You can keep a huge library of books. Not only a book stand, but a whole library. So it will again depend on the quality of the image you are creating. You have the physical documents, the quality of the scanned documents will determine the requirement of the memory space. Next, the types of memory. In the types of memory, we have the primary memory and the secondary memory. Basically, the computer is divided into primary memory and secondary memory. I have already told you that when you want to keep a data temporarily, you are keeping it on primary memory. When you want to back up the data for permanent storage, you are using the secondary memory. So primary memory is often known as the working memory or the main memory of a computer system. Primary memory is of two types, volatile and non-volatile. When the computer's power is turned off, the volatile memory loses its content. So when the power is there, the content will be there in the volatile memory. As soon as the power of the computer is off, it will lose all its content. The non-volatile memory, in contrast, does not lose its content when the computer is turned off. So it will keep the data permanently. RAM and ROM are the two major types of primary memory. They are made up of semiconductor memory material. A computer cannot run without primary memory. Now here you find two kinds of primary memory. One is RAM, another is ROM. Now RAM is a is a temporary kind of permanent memory, but ROM is a permanent kind of primary memory. Not all primary memories are temporary in nature. If you are using a ROM, it is not temporary in nature. If you are using a RAM, it is temporary in nature. So, for using a memory that will be permanent and it will be of very fast kind, you have to use a ROM, that is read only memory. They are made up of semiconductor material. Computer cannot run without primary memory. Primary memory should be there in a computer so that it can run, otherwise it will not be able to run. It may not have any hard disks, but the primary memory should be there. Then if a computer is not having a hard disk, it can take the where will the operating system come from? The operating system will be there in some server, and it will load the operating system on the primary memory through the network. It will boot through the network. It will take the operating system files from the server computer. So, requirement of primary memory, you understand, it is connected with the requirement of the processor. As there is a processor, as there is a CPU within the computer, each and every computer, it needs the primary memory to get the instructions from it. Otherwise, who will carry the instructions or the data on the system? At least for the temporary purpose, when there is power, you need the data on the system locally. So that is the purpose being met by the primary memory of the computer. Right? And there are two types of primary memory. One is RAM, another one is ROM. RAM is temporary, ROM is permanent. Now we will see about different kinds of ROM and RAM in the next tutorial. Okay, here about RAM and ROM, they are both are made of semiconductor memory material, and the computer cannot run without a primary memory. Memory is like a carpenter's shop. The raw materials are stored in another room, the hard drive, and the carpenter brings them into the workshop when they are needed. When the carpenter has completed the work, the finished piece is moved from workshop back to the room. So when you want to work on some object, you take the object to the workspace. So that is the workspace. RAM is the workspace, working area of the computer. You take the data from the hard drive, work on it, process the data, and keep it back to the hard drive. So that is the purpose of a temporary memory, RAM. A byte or character is the basic storage unit in the memory. When an application instructions and data are transferred to memory from storage devices, the instructions and data exist as bytes. So, when the data and instructions are transferred from hard disk to the main memory, they are stored as bytes. The data is stored as byte on a RAM chip. Each byte resides temporarily in a location in the memory that has an address. So there is also an address on the RAM chip where the data resides temporarily. And how it resides? It resides as a byte of memory space. Okay. So we will read about the types of RAM and ROM in the next tutorial. If you have any doubts up to this, that is up to this, you can comment and I will try to clear your doubts in my next tutorial. Thank you all.